We present Lookalike3D, a model for identifying identical and similar objects in 3D scenes. Repeated objects are extremely common in indoor environments. For instance, the three small tables in this scene. However, state-of-the-art 3D perception and generation methods, such as SAM3D objects, largely handle objects independently. This results in inconsistent reconstructions in the scene. Lookalike3D explicitly detects repeated objects and enables joint reasoning among them, in this case enabling joint object reconstruction consistent across the scene. We categorize object pairs into three types: identical, similar, and different. Identical pairs have exactly the same shape and appearance. Similar object pairs share semantic structure but differ in finer-grained geometry or appearance details. Our method, Lookalike3D, takes a scene characterized by an image or multiview images as input. For each pair of objects in the scene, we extract multiview crops and encode them with a pre-trained DynoV2 model into multiview patch tokens. These patch tokens are passed through alternating attention layers, which operate at the single view, multiview, and global levels, producing refined patch tokens that capture both local features and global context. We aggregate these features across the views and compare them between objects to obtain a similarity score. Each object pair is then classified as identical, similar, or different. We train the model using triplet and score alignment losses. At test time, our method can operate on single image views or multi-view images from a single scene. To support this task, we created the 3D Twins dataset, which contains 76,000 pairs of identical, similar, and different objects and their views derived from ScanNet++ scenes. We compare Lookalike3D against image matching and point cloud registration baselines. Our method significantly outperforms all baselines on both ground truth and predicted instances. Next, we demonstrate how identifying identical objects enables improved 3D reconstruction with SAM3D. While SAM3D reconstructs objects independently, often producing variations in shape and scale across repeated instances, we enable joint reconstruction of identical objects across their input images, producing a single clean representation of repeated objects. SAM3D also tends to produce incomplete objects for occluded views, while our method enables recovering complete object geometry. We also demonstrate the use of similar pairs of objects for joint part segmentation using P3SAM. While P3SAM produces fine-grained part segmentation of 3D objects, it may undersegment some objects. We use similar object pairs with shared structure to produce consistent part segmentation. For example, structures such as fused chair arms and legs can cause segmentation errors. Our method can recover finer-grained object parts from correctly segmented objects with similar structure. Thank you for watching.